Hello everyone, welcome to Petrobarrel. Today is the second video of the reservoir rock properties and we will talk about the factors affecting on porosity. So we have around 7 factors affecting on the value of porosity. The first factor, which is particle backing. For example, if I have 8 spheres or 8 sand grains, let's imagine that this is the sand grains of the reservoir rock, okay? And each sand grain has a radius r. Okay, and I take a section just like a cube in shape, okay, to get the volume of this cube. Simply the volume of any cube equal to the length by width by height. So the volume of this cube equal to 8r power 3, which is 2r multiply 2r multiply 2r. So based on this volume, this is the bulk volume, or this is the total volume of this section or of this cube. So based on the porosity, as I said in the first video, based on the definition, the porosity equal to the pore volume divided by the bulk volume, and the pore spaces volume equal to the bulk or total volume, this volume minus the matrix volume. Okay, and based on this section, if I'm talking about a cubic backing, so we have 8r power 3 equivalent to the bulk volume, and the matrix volume equal to 4 over 3 multiplying pi r power 3. Why? Because here in this section I see each sphere contribute with 1 over 8 of its volume. So 1 over 8 multiplying 8, which is the number of these sand grains, give me 1, which is the volume of one complete sphere. And based on the rules or functions we studied before in mathematics, the volume of a sphere equal 4 over 3 multiplying pi r power 3. So based on this, we have around 47.6% the porosity of cubic backing. But here, take care please, that the value of porosity independent on the value of r or the radius of sand grains if all sand grains have the same r or uniform in size. So based on this, the absolute sizes of the sand grains which make up a rock don't influence, or it doesn't making an impact on the amount of porosity occurring in the rock. And the variation in the porosity, okay, if I have different sizes for the sand grain, so the variations in the range of sand grain size do influence or doing impact on the value of porosity. But if I have uniform or same sizes of the sand grains, we still have a constant value of the porosity around 47.6 if I'm talking about cubic backing. But based on the rhombohedral backing without derivation, the particle backing of the rhombohedral backing, which is this shape, okay, around 26% as a porosity. Okay, so this is the first factor. The second factor, which is the particle size, as you see here, I have high variety in the particle sizes of the reservoir rock. For example, here I have large size of the particle size or the sand grains, and medium size and small size. So based on this figure, I have pore spaces in a gray colors. So based on this shape, or based on this condition at which I have high variety of the particle sizes, okay, it give me very low porosity, tend to be very near to 0 or 5% and so on. So why? Due to high variety or due to different sizes of the particle size. For example, if I'm talking about the pore spaces volume but in absence of medium size and small size, so all of these volume, okay, will be gray or will be pore spaces, so I have high porous formation. But here, due to variety or due to difference in the particle sizes, it gives me reduction in the porosity due to range of particle size. The third one, which is particle sorting, at which I have well sorted and poorly sorted formation. The well sorted, at which I have a better arrangement of the particles together. So this is well sorted. So as you see, the gray color or the light gray color is the pore spaces volume. So this is give me a high value of the porosity or give me indication of high porous formation. But here I have poorly sorted, at which I have different sizes of the particle shapes or particle sizes. So it give me low porosity or non-porous or tend to be non-porous formation. Why? Because based on well-sorted sediments, the grains are similar in size. So the value of pore spaces volume very high incomparable of this type. Okay, so the porosity is higher because there are more open spaces between the grains that are not filled by smaller particles. But here, the pore spaces have small particles, so it gives me high impact on the value of porosity, leading to a reduction of the porosity. So in poorly sorted sediments, I have grains but in different sizes. So it gives me poorly sorted and it gives me low value of porosity because the smaller size of grains fill the spaces between larger grains, leading to a reduction of the total void spaces. The fourth part, which is particle shape, as you see, I have uniform smooth particles and uniform angular particles. Really, the angularity of the sand grains, it gives me a low value of porosity and permeability due to the small value or the low value of the pore spaces volume. But here I have large pore spaces or high porous formation. So the angularity or flat or elongated sand grains and are packed together, for example, due to overburden stress, it give me low value of the porosity. And also it affect on the value of permeability. So the porosity and permeability may both be low, incomparable of uniform smooth particle. So here, this shape is well rounded. As you see, the matrix or the sand grains rounded, okay? And here I have very angular sand grains, which give me low value of the pore spaces volume. The fifth factor, which is cementing materials. As you see here, in any rocks, we have pore spaces, okay, which is black color. We have grains, which is the white color, okay, the sandy grains, for example. And I have matrix, which has size smaller than the grain, but still like grain. And I have cementing materials between the grains and pore spaces, which is like the coating or the material making each grain attached together. So this is the cementing material. So if I have high cementing materials, it take a volume from the pore spaces volume. So high value of cementing materials give me consolidated formation, to be honest, but it leads to reduce the value of the pore spaces or reducing the porosity. So based on the cementing materials, the porosity and permeability of a sandstone are both influenced to a marked degree by the amount of cementing material. The high value of cementing material, the low value of porosity. Okay, because simply the cementing material located or present in the pore spaces itself, and it take a part or it take a certain amount of the volume and leading to reduce the value of the pore spaces volume. So this is related to the cementing material, but to be honest, in formation strength, the cementing material is essential, crucial for the strength of the reservoir, because the cementing material responsible for attaching the grains together and make the formation easy to drilled without drilling problems like unconsolidated formations and always I see a lot of sands inside the well bore, so this is a big problem in the drilling engineering. But here I'm talking about the porosity itself. The cementing material is a good in formation strength, but it has impact on the value of the porosity because simply it take a volume or it take a certain volume from the pore spaces volume of the reservoir. Also related to the cementing materials, the cementing material may be located at pore throat. As you see here, this is the pore spaces volume, the pore body, or the main pore spaces volume. But here I have a narrow path, which is the pore throat. Pore spaces, but has a low volume incomparable of this volume. Okay, so it reduces the ability, the pore throat, if I have cementing material inside the pore throat itself, it reduces the ability of flowing of fluid, or it has a significant impact on the fluid flow inside the porous media. But to be honest, the cementing material inside the pore throat, it doesn't affecting significantly on the value of overall porosity. Okay, uh, as you see here, I have high pore spaces in the pore body, for example, but here I have, for example, if I have cementing materials here, it reduces the ability of the fluid to flow, not reducing the overall porosity. Okay, so this is another effect of the cementing material affecting on the value of porosity. The factor number 6, which is overburden stress. As you see here, the overburden stress equivalent to the weight of the rock itself and the fluid located inside the pore spaces of the rock. So with depth, the value of overburden stress increase. Okay, so let's imagine that I'm talking about the porosity of this formation. Okay, so this formation carrying any formation above it. For example, this formation and the top formation. So these formations has a weight of the rock itself or the matrix, and each formation, the first one and the second one, has pore spaces, and these pore spaces carrying fluid, either oil, water, gas, any type of fluid. So the overall weight of the formation number 1 and the formation number 2 affecting on the formation number 3. So this leads to a compaction. So the compaction reduces the value of porosity, to be honest. Why? Due to the compaction process, the pore spaces become very narrow or reduces due to the high weight above this formation. So the overburden stress reduces the value of porosity and permeability of the formation, especially in unconsolidated or moderately consolidated rocks. Why unconsolidated and moderately consolidated rocks? Because in unconsolidated formation, I don't have enough cementing material to make the rock itself or the formation strength rigid or hard. So the unconsolidated formation or the unconsolidated rock leads to easily movement of the grains and making the compaction very easy. So the high compaction, the low value of porosity and the low value of permeability. But if I have high consolidated rock, I have high cementing material, so I protect the pore spaces, so it give me high value of porosity and permeability incomparable of unconsolidated formation, at which the movement of the grains and the process of compaction very easy incomparable of high consolidated formation. So based on this, in unconsolidated or moderately consolidated rocks, the value or the effect of the compaction on porosity and permeability high, and reducing the value of porosity and permeability. So this is the factor number 6. And lastly, the factor number 7, which is vugs, dissolutions and fractures, at which vugs increasing the porosity significantly, because vugs here, as you see, I have large voids in the rocks, but sometimes the vugs increasing the isolated pore spaces, so it have high impact on the total porosity, but it doesn't make enhancement of the effective porosity. As I said before, we have effective porosity, we have isolated porosity, and we have total porosity. So the vugs affecting on the total porosity or the isolated porosity, but it doesn't give me enhancement of the effective porosity. The second one, which is dissolution, creates secondary porosity, at which we have enlargement or creating new pore spaces as mineral dissolves. As you see here, this is the dissolution. So the porosity improves especially if the dissolution is widespread or due to spreading of the dissolution, it gives me enhancement of the porosity. Okay, so this is the dissolution, and finally fracture, increasing the porosity but slightly. Why? Because the fractures incomparable of the spreading of the dissolution or vugs, the fractures give me like channels. So these channels or this path, okay, make me enhancement of the permeability or the fluid flowing, but it gave me high porosity to be honest, but not high, just slightly increasing in the pore spaces volume. So the fractures acting as a secondary porosity to be honest, increasing the porosity but slightly because their volume is small compared to the original pore spaces volume located in the rock, but the fractures making high impact on the enhancement of the permeability. So this is related to the vugs, dissolution, and fractures, and all of these types considered as secondary porosity, at which this is the porosity creates after the deposition of the materials or after the deposition of the sediments due to the formation of sedimentary rocks. So this is all about today's video. I hope this video is useful for you. If you have any question, please write me a comment. And thank you, and assalamu alaikum wa rahmatullahi wa barakatuh.